In this video, we are going to talk about potential energy. So I gave you an example was what it meant by potential energy. Yep. Before I do that, just remember there are many different types of potential energy. However, now we're dealing with gravitational potential energy. It's basically the energy needed to against the effect of gravity. Okay. Let me give you an example. Now, I have the ground here, and I have two tables, table 1 and table 2. Table 1 is 1 meter high, and table 2 is 2 meter high. So my task is to move this rock from the ground onto table 1 and drop it back, then move it to table 2. Yep. Okay. Now, you can do the same experiment, and I guarantee that you'll find it is a lot harder. It takes more effort to move the rock to table 2 rather than table 1, because table 1 is shorter and table 2 is higher. Okay. But let's look at this scenario by force first. Okay. So if I draw a free body diagram on this rock, I have the weight force acting downwards, which is mass times gravity. Then I have a normal force acting upwards. Okay, so when I try to lift, this rock up, I need to apply a force equivalent to its weight force, at least equivalent to its weight force. However, I can apply more forces, but the idea is the force I applied to lift this rock on table 1 and the force I applied to lift this rock on table 2 will be the same, can be the same, it just need to be greater than its weight force. Okay. However, it takes a lot more effort to move this rock on the higher table. Okay. That's why physicists developed energy. Okay. We need to apply more energy to against gravity on a higher altitude. Okay. And we call this type of energy potential energy. So if you look at say if I have the rock on table 1. Now, let's have a look at the work done on this. Okay. Now, remember what we learned before? The work done is basically force times the distance. The force I need to apply to against gravity will be the weight force of the object, which is mass times gravity. Okay. The distance it traveled upwards here will be 1 meter, will be the height of the table. Okay. So we have the work done against gravity as mgh. And this is basically our new formula for potential energy, which is measured as mass times gravity and times the height. Yep. Okay. Okay, now let's do an example. But before we do the example, just remember, write this equation down on your cheat sheet. Okay. So in this question, we need to find the potential energy of a mass of 2 kilograms at a height of 100 meters. Okay. So just use the formula mgh. Let's use gravity as 10 meters per second square. So I have 2 times 10 times 100, which is going to be 2000 joules. Okay, so this means now in order for that rock to be at a height of 100 meters, someone or something or somehow 200 joules of energy is applied to it. Okay. As a result, those energy 2000 joules of energy is stored in the rock at 100-meter height.